Let us write an equation for a function with the given vertical and horizontal asymptotes. So notice that we have a vertical asymptote here at x equals 2, and we have a horizontal asymptote here at y equals negative 4. Well, a vertical asymptote comes from the denominator. So we need a function that has a denominator that would give a vertical asymptote of x equals 2. Now, a vertical asymptote of x equals 2 would come from a denominator of x minus 2 because of the way you set this equal to 0 and solve in order to actually get the vertical asymptote. All right, so the denominator needs to be something like x minus 2. Now, meanwhile, we have a horizontal asymptote of negative 4. Now, when we deal with horizontal asymptotes, we must be very careful. The horizontal asymptote depends on how the degree of the numerator compares to the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. If the degree of the numerator is equal to the degree of the denominator, then it's y equals a over c, where these are leading coefficients. And if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. So we need to use these rules to guide us to having a horizontal asymptote of y equals negative 4. So one way to do that would be to use the situation where the degree of the numerator is equal to the degree of the denominator. So if we want the degree of the numerator to be equal, notice that the degree of the denominator is 1, because this is like having x to the 1 power. So if I put an x up here, then that makes this degree 1 as well. So now the degrees are equal. So right now, the way I have it, the horizontal asymptote would be y equals 1. Because when the degrees are equal, you do the leading coefficient over leading coefficient. And right now that's 1 over 1. Now we want the horizontal asymptote to be negative 4. So if we put a negative 4 in front of this, then all of a sudden now we have a horizontal asymptote of y equals negative 4. The degrees are still equal. The degrees are both still 1, but now I have leading coefficients negative 4 over 1, the invisible 1. And that makes y equals negative 4. So this is one solution to the equation. So this would probably be the most common solution. Another solution would be to use the idea of having the degree of the numerator be less than the degree of the denominator. That would make the horizontal asymptote y equals 0, and then we can adjust from there. So I'm going to do this in green. So this is an alternate answer. Okay, so here's another answer. All right, so again, we still need the denominator to be x minus 2. So that'll give us x equals positive 2 when we set it equal to 0 for the vertical asymptote. Now, I can put any constant up here, and that will be degree 0. So it could be anything. You know, I could just put a 3. But this could be any constant. So right now I have degree 0 up here. So at the moment, because I have degree 0, degree 1, the numerator degree is less. That means I have y equals 0 for my horizontal asymptote. But I wanted it to be negative 4. So all I have to do is make an adjustment and put a minus 4 on the end. that will drop the horizontal asymptote down 4. You know, it would be 0, but if you subtract 4, then it moves it down to -4. So now I would have a horizontal asymptote of y equals -4. Okay, so this is another version of the answer with this number on the end. All right, and this could have been a 3 or a 5 or a 7 or anything you want. So I'm going to go ahead and erase the 3 and put C for constant, just to reflect that you could put any constant you want in there. So there's your alternative answer. Find a decimal approximation for the x-intercepts of the following function. Remember, to find the x-intercepts, what we do is we let y equal 0. Alright, in this case, y is this whole thing. So we're setting the entire function equal to 0. But guess what? The denominator can't be 0. So the only way the function is going to equal 0 is if the numerator equals 0. So it's like we're setting x squared minus 5x minus 8 equal to 0. And we're solving this. So normally we would factor this, okay, but 8 is like 2 times 4, 1 times 8. I'm not going to get a 5. This is unfactorable. That's why they're saying decimal approximation. So we have to solve this some other way. Let's use the quadratic formula. The quadratic formula is like this. It goes, given something like this, we've got x will equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. To help us remember that, we used to have a song. I don't know if I can sing because I'm losing my voice. I'll try. It was like opposite of b plus or minus square root plus or minus square root b squared minus 4ac b squared minus 4ac all over 2a all over 2a. Wow, that was awful. Alright, anyway, so this is what we're using. We learned to first find the discriminant, which is this part. Okay, so let's do that right now. So we're finding the discriminant, the b squared minus 4ac part. Okay, of course a is 1, b is -5, and c is -8. Okay, so b squared minus 4ac, that's -5 squared minus 4 times 1 times -8. I'm just going to put this in the calculator. Alright, this is what it looks like in the calculator. Notice my use of parentheses. This is mandatory. If you don't use parentheses around this -5, you will get the wrong answer. Okay, so 57. The discriminant is 57. Okay, so that means that we've got 57 right here. So let's go ahead and do the rest of the quadratic formula. Okay, so that means x is going to equal opposite of b. So b is -5, so the opposite of b is +5 plus or minus square root. Alright, we already did this part. That's 57 all over 2a. Well, a is 1, so 2a will just be 2. Okay, so this will give us our x-intercepts. So let's turn this into decimals by putting this into the calculator twice. Once as a positive and once as a negative. Okay, so 5 plus blah blah blah. Here we go. Okay, fraction mode. So 5 plus radical 57 over 2. Enter. Alright, first it just switches these around for some reason. I don't care about that. So I'm just going to hit the toggle button to get the decimal. Okay, so I'll do 2 decimal places, the nearest hundredth. So that's 6.27. Okay, 6.27. Now I'm going to type it in again with a negative instead of a positive. Okay, now I don't really have to type the whole thing in again. If I want to take it easy on myself, I can go back to the first time I typed it in and just hit enter. Okay, now I can just arrow my way over and change this to a negative and hit enter. Okay, again it just switches it around first, but I'll just toggle it. So that gives me negative 1.27. Alright, of course I could have just typed it in again with a negative if I wanted to. But we're doing X-intercepts, so let's write this as an ordered pair. Okay, so these are X-intercepts, so these are X values. So that means I'm talking about 6.27 comma 0 and negative 1.27 comma 0. Okay, and that's it for the bonus, and that is also it for this entire test. Alright, you guys, I hope this video was helpful. If you're studying for a test of your own, you know, for my students, that would be recovery. The key is to make sure that you can do every single one of these problems by yourself. Doing it along with me just gives you a false sense of security, making you think you know what you're doing when you really don't. You don't know if you can do it until you sit down and try to do it by yourself. So make sure that you do. Alright guys, I'll see you on the next video.